Hey everyone, thank you for joining us for our second Q-PAC Lunch and Learn. We are soon to be rebranding it as Quick UnPAC. That'll be our next one. But my name is Eddie Legaspi. I'm the new promotions coordinator over at Q-PAC, and I will be emceeing today. So if you have any questions, please feel free to put it in the chat. I'll interrupt Kurt and Mo, and we'll kind of get you pointed in the right direction with an answer. So we're thrilled to have you. We're going to dive in here shortly to applications and solutions of the Q-PAC FS1 system. The first thing that I will mention right at the start is you are the first to hear about it. We will be hosting the Q-PAC Summit October 18th and 19th here in St. Augustine. We will have speakers, we will have factory tours, we will have events and programming for you all. So please mark your calendars. We would love to have you down in sunny Florida, especially when that autumn weather hits wherever you're at. So please mark that, and I will remind everyone again at the end of the broadcast. But now, without much further ado, I will bring in Kurt, our head of marketing, and Mo, our sales manager, and we'll be talking about the applications and solutions of the FS1 fan system. So I will make way for Kurt. And
what's going on, everybody? All right, let's see. Eddie, I don't think I can change the slides unless you want to run those for me.
There you go.
Appreciate it. All right, I'm glad everybody joined. This should be a lot of fun. We're going to talk about applications. So sizing your fan system in the field. We'll cover the sizing limits, what is too big, what is too small as far as dimensions, airflow, and static. We're going to talk about dampers. When's a good time to use dampers? Backdraft dampers specifically. We'll also cover some rules of thumb on harmonics and talk about what even is harmonics. We'll talk about the required and recommended clearances upstream and downstream of one of our arrays, structural support requirements, and an example of an install gone wrong. We'll also talk about some efficiency metrics. So let's dive in. All right, sizing your system in the field. So first of all, shout out to Kevin Kelly at Florida Applied Products for allowing me to use this action shot of him. So I'm just going to cover some basics. What do you need when you are going to the field? Every job site's a little bit different, but I always recommend having a notepad, a pencil, measuring tape, a headlamp, a camera, and a step ladder. And I always recommend too, like whenever you're there for the first time, go ahead and take measurements so you don't have to return to the job site multiple times to double check all of your measurements, record them, and yeah, it'll save you time for sure. So sizing your fan system for a field upgrade. So look, we have many different sizes of fans. Ideally, you want to choose a fan that can fit through the existing access door, right? But you also need to check the access of the entire building. So mechanical rooms can get weird, as we all know. There's a lot of random pipes and ductwork that you have to walk around. Walk the path all the way from the loading dock to the inside of the air handler. All the components can be turned so they can go through a normal standard door, but depending on the height or the size of the air handler, our bulkheads can actually get up to 140 inches. So you want to make sure that you're bringing in the components, or if you bring in the components to the service elevator, make sure that they can fit the height of our bulkheads. Airflow requirements and static pressure. So I always recommend a TMB report, testing and balance. It can save your customer a lot of money. A lot of systems, in my experience, are extremely over-engineered. Nobody's going to get fired for oversizing one of these fan systems, but you may get fired or get in trouble for undersizing. You're going to have bigger issues, right? So everybody adds an inch or 2 inches of static pressure, and it just adds up. So do a TMB, save your customer some money, get the right size unit in there, and just do your homework and understand the real requirements of that system.
Kurt, we were asked 140 inches in what direction? Oh, perfect. Thanks, Mo. Height of the bulkhead.
Height of the bulkhead, yeah. So, and I think the width of the bulkhead is what, 36 inches, or no, 40, what is it? About 44 inches wide. So you can always turn something but 100, so 44 inches to 140, I think, is the maximum dimensions of our bulkhead. So
The entire bulkhead would be 20.
well, yeah, that single piece of the bulkhead. Thanks, Mo. So available power in the building. Our offering includes only 3-phase fans. So you need to record the voltage. So whenever you're selecting the correct fan in Quips. So also the existing breaker size, right? Most of the time installing our product is going to reduce the amount of energy that's required for the fan system, which means that you can reuse the existing electrical infrastructure already in place. And so what do I mean by that? If you're replacing a VFD that feeds an AC motor, you can remove the VFD, install our control panel exactly where the VFD was. You don't have to run any new electrical wire or change the circuit breaker. And then you can even reuse the wire that goes from the VFD to the motor inside the unit. Instead, you can rewire that to our control panel and our quick connect box. So it makes the install super easy on the electrical side.
2 quick questions for you, Kurt.
Yep.
At what point from a width do you need to add secondary support for deflection?
From a width, so that's a good question. That also depends on probably the static pressure as well. Our units or our bulkhead's really strong. We really don't have an issue with deflection as long as the perimeter is secured. And Mo's going to talk about the structural support in some later slides.
As well as, will we have 575 volt for Canada in the future?
Currently, that is not on our roadmap. So in Canada, it seems that every building that has 575 also has 240. So we recommend doing 240. There's also a lot of transformer options where you can go from 575 down to 460 or 480. So not currently on our roadmap. And then the last thing is control type. So what does the customer want? Do they want to connect to BACnet? If they don't, they just want to feed it 0 to 10, you can use our basic option. So just understand what your customer wants and you can select the correct control type. So, all right. Sizing limits. So as far as width is concerned, 28 inches is as small as we'll go, up to 280 inches. So I have the red asterisks in there because really we don't have a limit on the width. I mean, you can stack our fan systems you can just stack as many as you need to infinity, really, and get as much airflow or as much width as you want. But 280 is the limit on Quips. So if you need to go beyond that, or you need more than 2 fan arrays like you see in this picture, then just add a note in the specials column. Height-wise, 26 inches is as small as we'll go, and 140 inches is our limit. That's the limit of the sheet metal that we buy. So, pressure and airflow. So static pressure. So I'm showing what we call our full range. So this is what we're capable of doing. And then I'm showing what our sweet spot is. Sweet spot meaning where we add the most value. And I'll talk a little bit more about that depending on if it's static or airflow. So for static, we can do up 0 to 10 inches. We have the capability, we have the fans to do it. Sweet spot, we provide the best ROI between 2 inches and 6.5 inches. So that's where you'll gain the most value when selecting a static pressure range. Airflow wise, we can go from 0 to no limit. We can stack as many fans as we want. You can buy as many systems as you want and put them in the same common duct. Our sweet spot, really 10,000 CFM to 160,000 CFM. 10,000 CFM because that's when you'll get into more than one fan. We will sell you a 1 fan array, but you'll definitely gain the most value when you have multiple fans. I mean, that's kind of the point of having a fan array is whenever you have more than 1 fan. The reason I show 160,000 CFM is only because that's the current limitation of Quips. Obviously, you can stack more and more of these, and we really don't have a limit on airflow.
2 questions for you, Kurt.
Yep.
Can we order loose fans and control panel without the factory bulkhead? That's the first question.
No, you got to have the bulkhead. So the bulkhead is it is a very highly engineered product. So every single fan and harness is placed at a certain location on the bulkhead. The harnesses are at the specific length, and we even have pre-punched holes to, excuse me, to place all of our harnesses on the wall. They're all pre-routed and pre-engineered through code. So you can buy loose parts as far as fans after the fact to install an existing system, or if you want a spare. I always recommend buying our bulkhead. It's going to make your life a whole lot easier.
And then second question, can the bulkheads be installed horizontally?
They can, yeah. So there are some cases where a horizontal bulkhead does make more sense. Whenever you have that case, type in a note in Quips, and you're going to get some questions, so be prepared to answer why. We want to make sure our product is being installed correctly and there's not going to be any issues. But yes, we can do that. Good questions. All right, backdraft dampers. So when's the best time to use a backdraft damper? I say never. So the reasons why, it's an energy leach, right? Like we assume 0.2 inches of additional static pressure every time you add backdraft dampers to our system. We provide blank off plates, so if you do have a failure, it doesn't take any time to walk up there, take the 8 bolts out of the fan. It's 2 plugs you have to unplug, and then you screw on our blank off plate. The recirculation of a failed fan we're working on data, but it's really not that much. And most customers don't even know when they have a failed fan if they're not monitoring their fan array status. So I always recommend not to buy backdraft dampers. There are times when people need them. Look, hospitals require them a lot of times. Sometimes they're spec'd and you just can't get around it. And we actually have a great solution for it. So we have the option. If you can't get around it, you can order it, but I prefer not to. We make a lot of money on our backdraft dampers. I'm not going to lie, we have a great solution, but it's not best for the customer, in my opinion. Harmonics. Okay, so this one's fun. So I asked ChatGPT-4 to explain to me what Harmonics is as if I'm a 10-year-old, and this is what it told me.
Kurt, to pause you before you get into Harmonics, we have one damper question.
Yep.
That was the second question. Will you offer actuated isolation dampers instead of backdraft dampers?
We do not. Yeah, we do not offer any isolation dampers.
Okay. And when we design, can we quote unquote oversize for a failed fan configuration?
Yeah, absolutely. That's a good question. So in Quips, you can always ask for N+1, right? And I think it's a great solution, just an additional fan. So if one fan fails and you have that other one, but we also stock we have 1,500 fans in stock right now. So if you do have a failure, we have dedicated stock that we can ship in emergencies, and you can have it, in a day or two. So depending on the application, you don't have to do N+1 because we can get you a fan really quickly, but some hospitals or other critical applications, it does make sense.
Sorry to interrupt. Now back to Harmonics.
Back to Harmonics. All right, back to ChatGPT-4. So this is how ChatGPT-4 would explain Harmonics to a 10-year-old. All right, kiddo, imagine you have 3 friends named Red, Yellow, and Blue, and they are all on the playground swing set, swinging back and forth. When they swing together, they go in a smooth and balanced way, with each of them taking turns reaching the highest point of their swing. This is like 3-phase power. Now let's say some bullies come over and start messing with your friend's swings. They shake the chains, making the swings move in a strange, wobbly way. This creates a weird and less enjoyable swinging motion for Red, Yellow, and Blue. The entire swing starts to wobble. This is like electrical harmonics, unwanted wobbles or disturbances in the smooth flow of your electricity. These wobbles or bullies can be caused by some devices or machines that don't use electricity smoothly, making it harder for other things to work properly in a 3-phase power system. If we want everything to work right, we have to find a way to make the bullies go away or calm down so they don't create an unacceptable level of disturbances so everyone can happily swing back and forth. I thought that was a great explanation. And another thing to mention, the Harmonics, so a lot of people reference IEEE 519 for Harmonics. That is a standard at the point of common coupling and not a component standard, which means that whenever you're checking for harmonics, you need to check for it at the transformer that's feeding many, many devices in the building, and not just a component. So the components can add up and cause a lot of disturbances at the point of common coupling, but as I have in a note here, in the history of Q-PAC, we've had 1 in every 1,260 jobs has had a harmonics issue, so it's not common. All right. So there's some rule of thumbs. If you're worried about harmonics, then there's some things to look out for. So if you're replacing a standard 6-pulse VFD with an ECM fan, you're more than likely not going to have any issues. We did some testing comparing VFDs to EC fans, and EC fans were actually had a couple points lower total harmonic distortion than a 6-pulse VFD. One threshold, if it's to look out, is if the fan system is 100 amps or less, it's not even worth looking at. You're not going to have a harmonics issue. So if it's 100 amps or more, sure, let's start to evaluate it. You have an issue, or definitely look out whenever you're replacing a linear load with a non-linear load. This means that if you have a system with basically 100 amps or more directly connected to an AC motor, meaning there's not a VFD involved, and you're replacing that system with an EC fan array, that might be a flag where you want to look into some harmonic mitigation, or at least be aware of it in case there are issues after the install. So another thing to look out for is existing harmonic filters. So, and larger buildings especially, a lot of telecommunication companies like AT&T or T-Mobile or Verizon, they place some devices and antennas inside of buildings. They measure for harmonics, and if the building has some issues, they put their own filters in there. So that's a pretty clear indicator that the building has some dirty power and some harmonics if there are other harmonic filters already in the building. It's not common, but I have seen them. So what does happen whenever you have a harmonics issue? What does it look like, and how do you identify it? It's typically nuisance fuse tripping and a buzzing sound coming out of our control panel. One clear indicator is whenever you are measuring, if you have a CT or a fluke and you're measuring the amperage on one phase of our control panel, and it's below, the current is below what the fuses are rated for, and they're still tripping, that's an indication of harmonics.
Couple questions for you, Kurt, before we move on.
Yep.
Do you have a harmonics calculator we can use ECM versus VFD?
I do not have a calculator.
So Kurt, I think you're going to talk about some options. I know that TCI has a calculator on the website that people can use.
Interesting.
It's based on a lot of assumptions, so I wouldn't take those numbers for something that will happen, but there are calculators out there. Some of them are online and you can use it.
Gotcha. Did everybody hear that? Let's go to the next slide, Eddie. So following what Mo was saying, we don't have a calculator, but TCI has one on their website. If you do have an issue with harmonics, we know who the experts are, and it's TCI, and Zeolabeg also has an active filter solution. TCI specifically, all they do is they make a bunch of devices. A bunch of them are for harmonics. They have a calculator that you can go onto their website, and they have this brand new passive filter specifically designed for ECM fan arrays. If your fan array has Zeolabeg fans, Zeolabeg also has a solution, and we will connect you with them so you can figure out exactly what you need. So, any other questions around harmonics, Eddie?
Someone didn't fully hear what Mo was saying about the calculator. So if you don't mind just running through those really quickly again.
Yeah, definitely. I have not been on there, but TCI, if you go to their website, they do have a calculator. It's whenever you're calculating or you're trying to predict harmonics beforehand, it is a bit of a guess. And I mean, I think TCI, out of all the companies out there that handle harmonics, they're definitely the best that I've dealt with. So I would trust their calculator more than others. But also know there's still some margin of error.
Perfect. Go ahead, Kurt.
All right. So thanks, everybody. I'm going to hand it off to Mo, and he's going to talk about the design in an AHU and the clearances.
Yeah, everybody, thanks for hanging with us. We know we said until 2 o'clock, but all these questions and interactions are really making it go really smoothly because we're getting a lot of information, but it might make us run over a little bit. So thanks for bearing with us. Again, if you have any questions, please put them in the chat and I will happily stop Kurt and Mo. I love stopping Kurt and Mo and passing the questions to them. And at the very end, if your questions have not been answered, we will have another just open Q&A session for anything that's still lingering. So now passing on to Mo.
Hey, thanks, Eddie. Thanks for joining. Good afternoon and good morning to some of you. My clock still says 10:52 a.m., so I'm sure some of you are still experiencing morning. And thanks for joining. Thanks, Kurt, for the great slides and the great questions. Please keep them coming. And this portion, I'm going to go through a few of the frequently asked questions that I get every week. Some of them I get daily. And please, if you guys are just going through some applications that are similar or have stories or want to just share something with us, please go ahead and type in your comments. So the first question that I get a lot would be how a fan array, specifically a Q-PAC fan array, works when it is placed in an air handling unit. Most of the fans, when you place them, they're going to interact with other components. There's going to be a coil that would heat or cool the air. There's going to be a filter. There's going to be energy recovery. So you're going to put the fan in relation to all these other components. The most frequently asked question is, what are the clearances when either it's a new air handling unit that I'm just designing a Q-PAC fan array, or it's an existing air handler that we are adding some component or changing the components? What would be the required clearances for a fan array? Let's go to the next slide, Eddie. So the first thing of designing air systems is to avoid abrupt changes in your airflow. So we don't want to have an abrupt change. How to avoid that? There is a good rule of thumb for this. Whenever you're going from one duct to another duct size, let's keep at least a 45 degrees transition. So you can see how I define that angle there. So I want to keep it 45 degrees or less. When I'm going from a coil to a fan, going from a wide, large face area, I'm going to a smaller inlet of that fan. So I'm going to keep it at 45 degrees. You can see there, and that requires some distance between that coil or filter or energy recovery wheel to that fan. And if I'm not keeping that required distance, I'm going to have some inefficiencies. There's going to be large pressure drops that I don't anticipate in my design. So there's going to be some design issues later on in the field. Now, if you see that I have a picture of a single fan there, and when I'm designing it with a single fan with a smaller inlet, I'm going to have to keep a larger distance between that component and the fan. Now, if we change that one to a Q-PAC fan array, we have a lot more flexibility. Now we are designing our fan array to go across that span of our bulkhead of our air tunnel. So now we have a much larger effective inlet compared to that one single fan. Now, another rule of thumb here for designing Q-PAC fan arrays inside of an air handler is that a foot, 12 inches would be enough upstream of our fan array. And now that gives me even enough space if I'm dealing with a cooling coil to have a drain pan there and to get rid of the the condensation carryover if I'm designing with, normal speeds, 450 feet per minute, 500 feet per minute on that coil. Now, if I'm working with a single fan of a similar size, again, it really depends on the height of my coil, the height of my system, but it's something between 26 inches to 36 inches clearance that I need upstream of that single fan with a single inlet. Same thing for downstream. You normally need more space downstream of your fans, just because the way centrifugal fans work, they take air with one inlet and then radially push the air out. So you have to give it some space to develop, so you have a uniform flow on your component downstream of the fans. Again, just because we are breaking up a larger fan to smaller fans with smaller wheels, wheel diameter, and air is going to break up between those smaller fans, you need a smaller space between your fan array and the next component downstream. The rule of thumb there is to use one diameter of that fan downstream, so at least to keep that distance. And it really depends on the size of the fan that you're using. Our fans are normally less than 24 inches of diameter, so that would be the ideal distance that we want to keep downstream of the fan array. That is the distance downstream. And I think we got a question on vertical flow. Sometimes you can have Q-PAC fan arrays mounted vertically in an air handler, and sometimes you have a side or top discharge for a fan that has a horizontal flow outlet. So again, this is the same. It's highly recommended to use guide vanes when you're changing the direction of the flow. But if you're not using that, that 1 foot distance would be required to the midpoint of your outlet, either on the side or top.
Mo, quick interruption.
Yeah.
Downstream clearance for coil versus filters the same?
Yes, so that would be pretty similar. Again, when you're designing the blow-through system, you're not going to get as good of a flow distribution on your component, either coil or a filter. So it's always recommended to use a draw-through system. I know that's not going to be always the case. There are times that you have to go with a blow-through, but yeah, that would be the same. Again, designing the speed, the face velocity on your component would be very important. So make sure that you're designing it with the right number.
And then one more question. From a bearing standpoint, does horizontal to vertical change the longevity?
That's a very good question, and I may not have an answer for it. I do not think that it would have an impact on the longevity, but I'll have to follow up on that, to be honest. Yeah. Good question, though. And for top or side discharge, if you have, again, we're working our entire fleet of fans are centrifugal single inlet, single outlet fans, single width fans. And if you have a one row of fans or one column of fans in a side discharge, then you can have your discharge opening right above the fans, because there's no interference between the fans. You're not having multiple rows or columns of fans, so that in this case, as you see, I have the opening right above the fans. The other question I get is regarding efficiency and specifically on the metrics. So these are, I'm going to go through the two metrics of efficiency that currently are used in ASHRAE 90.1, how we can get that for our fans. The first metric that was introduced a while back by 90.1 is fan efficiency grade, and we call it as FEGs. FEG is a single value per fan. So a fan, every fan has a single FEG number that comes with it. It is tested according to AMCA, and it is also listed and published by AMCA, by all of the manufacturers that follow. There is an AMCA library that you can find all the FEG values of the fans that you're dealing with if they are certified. And you can find that for all of the fans that we use. And it's extremely simple for our fans. And that's 80 for all of the fans that we use. So the minimum FEG requirements by ASHRAE 90.1 is 65. So you have to have a fan that is above 65. And as you see, all of our fans have FEG of 80. Again, you can go through the website. I have the link. I'm sure Eddie is going to send this presentation to you, so you guys can follow that link to get the FEG values of the fans. FEG is slowly going away. In 2019, both AMCA and ASHRAE 90.1 worked together and came up with a new efficiency metric. That is the fan energy index. The fan energy index is a calculation of an entire fan system. So right now, you're not looking at only the fan wheel efficiency. You're looking at the efficiency of the entire system, including the motor, including the belt, and everything else. And it is a calculation, as I said. Right now, unfortunately, our software doesn't spit out FEI for every system, but we have a separate calculator that you can use to get the FEI values for our fans. It's basically a very rudimentary spreadsheet, but the good thing about it is that you can use it for other fans as well. So I really like FEI because it's an amazing metric to compare the fan efficiency together. You know, it's an app, creates an apple to apple comparison. You can look at a fan with an FEI of 1.5 and a fan with an FEI of 1.0, and how they compare is just 1.5 divided by 1.0. You see how much more efficient one fan is compared to another fan. The ASHRAE 90.1, it's pretty new, the 2019 revision, so a lot of states have not adopted it yet. I think it's only the West Coast. I think Washington and California are the only ones that are using FEI right now. I'm sure a lot of other states are going to join in and adopt the 2019 revision. So it's going to come very soon. Even if your state or your building energy efficiency code doesn't require FEI, it's a good metric just to see how efficient your fan is. I think there's a question on FEG. Does not include the loss of a motor. Yes, exactly. So FEG does not include the loss of a motor, but FEI does. So I think that's a very good step from the code in the right direction to show actual efficiency of a system. And I have structural support for our fan arrays. This is a question that sometimes comes. A lot of our systems may go into an air handler that is already designed to have a fan array in it. But a lot of the times that's not the case. You're working on a retrofit system, and you're replacing an existing fan that is a completely different fan. So the support may be different. It may be a built-up system. It may be just an air tunnel that you're adding a new fan array in there. So the support may not be there for the fan array. The most important thing is that when you're putting the bulkhead wall there, it has to be supported on all four sides. It may sound very, common sense, but sometimes it has happened. I had a situation that I had to deal with. And this is a project that I worked on. It's a very high static system. This was the first time the contractor was installing a fan array at all. So this was the first time they were installing a fan array. And if you can see on the left of that picture, they basically had no support on the left or the right. It was replacing an existing fan that was on a very robust concrete pads. So the bottom of the fan array was very well anchored to the bottom, but they didn't have good support on either side of the fan array. And the top was not really anchored well. It was anchored basically to the liner and the insulation, and not to something structural. Fortunately, our bulkheads are designed to handle a large pressure differential, so that the bulkhead really had no problem here, and they have to just put some reinforcement. So as you see, they put some 4x4 structural beams on either side, and they also put some reinforcement at the top. And then they ran it. This system was at 8 inches of pressure differential. So, and a very large bulkhead, if the pressure times that area would be the force. So that force can be very large when we're talking about the large bulkhead. There was another question regarding, when we recommend to use reinforcement. Again, if you're going to combine multiple bulkheads, so if this is a system that goes beyond that 280 inches, that then we have to provide you with multiple bulkheads, then between those two recommend to have similar reinforcement, to weld a structural beam, a 4x4 beam, so that your structure is supporting both of those bulkheads. But if it is one span of bulkhead, then you just need to have structure around on the perimeter, so that the perimeter angle would go around. And that's all for me. If there are any questions, Eddie?
We had a quick one that Kurt started to answer. Hugh asked, are you hearing anything that DOE is discussing in a true wire to air?
Yeah, now I'm going to read Kurt's comment, but the FEI is the closest right now we've got to a fairly true wire to air. So it does include the motor inefficiencies, it includes the belts inefficiencies, and how it works. It basically compares the efficiency of your fan system compared to a baseline fan efficiency. So that baseline is a belt drive motor, and ASHRAE 90.1 basically wants every fan to be more efficient than that baseline. So they want a FEI above 1.0. So I think that's the closest we've got so far to a true wire to air efficiency comparison.
Next question, will you offer fan safety cages?
Fan safety cages, very good question. We do not offer that right now. I know there are a lot of applications that you're required to have a safety cage. So we recommend getting that, through a contractor at the moment. So yeah.
Next question, will you ever be able to select a bulkhead with an access door?
Yes, that is. And hopefully that will be much easier with our next revision of QIPs. But right now that is a special, but it's a very easy special for us to do. And it's actually a very good idea to get it if there's no access to upstream of your fan or fan array. It would be great to get that on the bulkhead.
Next question from Hugh. Will FEI then deal with the losses of a VFD/ECM drive?
No. So it is the fan and nothing upstream of the fan. You're correct. That does not include. It does include the ECM drive, because ECM drive is in fact included in the fan, but not the VFD.
Perfect. And if any of you see comments from Mark James, he is our product manager. And so those are legitimate answers, not just somebody messaging things in the chat. So we do anticipate offering fan safety cages in the future. Ben asks, any acoustical options like Temtrel fan cubes?
Not at the moment. We do not. So I think it would be a good topic to talk about acoustics. Actually wanted to add a couple of slides, but it would have taken a long time to just go through acoustics. It's we do not offer any acoustical mitigation on the fans themselves. Although it's good to look at how EC fans sound works and compare that to other systems. So yeah, I think that would be good to talk more about that. No offering right now, but our software does give sound power info. That's very easy to compare. But yeah, the answer is no.
Any other questions before we sort of start to wrap this up? Give you guys a couple seconds if you have anything. In the meantime, just a reminder that Q-PAC Summit will be October 18th and 19th this year in St. Augustine. We will be putting together a page for you all very soon with registration information, options in terms of where to fly into, where to stay, where to eat, everything, including who the speakers will be, what kind of presentations we're going to do. So we're finishing building the campaign for that, but that will be out to you all in the near future. And you all are the first to hear about it. So we would love to see some of you all down in St. Augustine later this fall. Looks like Peter House mentioned something about Paul quoting fan outlet cages. So it looks like he posted his information up there for Paul Fleck. He did ask, is it a sound per fan or do you speak to multiple fans?
We speak to multiple fans. So that's what comes out of our software would be a fan array sound.
Perfect. Yeah, any other questions, feel free to keep popping them in. If anybody does want any of these answers, we will be parsing this out and I will be getting this out to you, hopefully within the next few hours, just once it finishes uploading and we can get it there. Looks like Alyssa's already telling us she will be the first person there with us this fall. We're excited to have you. It's beautiful weather in October and I already know the best dinner in town. So I would happily pass that along to you all. Yeah, so like I said, we're going to get this recording to you all. It will be available. We'll email it to you as well as it will be posted on our LinkedIn with access to our YouTube page. So these things are live and we will be sending out micro content if you have any direct questions that need to be answered. Ben asked, can we get single fan sound data in an array?
You can definitely get that. Easiest way would be to just select a single fan and get that data. That would be the single fan data. But yeah, you're always welcome to contact your sales manager and get that data too. But our software does give you the sound power data. And if you select the one fan, then you'll get a single fan sound data. Yes. Let's make sure that maybe for one of our future webinars, we can include acoustics. So that,
yeah, they may have just picked what we're doing in May.
Yeah.
Lucas says one thing of note is to reduce the size of the first page on the Quips generated submittal. IT is always huge compared to the tech data pages. Please and thank you. We'll definitely take that into consideration, Lucas, and I'll pass that along to people much smarter than me. Everyone else is saying thank you. Hugh wants definite on the sound discussion. So like I said, maybe you picked what we're going to do in May. We'll have probably Kurt and Mo again, hopefully. Next question, what percentage of your fans are going in retrofit versus new construction?
That's a very good question, Asif. I may not be the best person to answer that question, but the market is, I would say, fairly split for us, at least. But yeah, that'll be a good question for you, Eddie, in marketing to get the data.
You're giving me extra jobs. I love it.
Well, you just gave me one.
Yeah, we can definitely start to actually offer some of those breakdowns. And Kurt, as my boss, who's the other presenter today, head of marketing, who's also been an engineer for the company, we will definitely make sure we're going to start putting together a lot more studies to start getting you all empirical data to really look at and see how we're driving things and how things are working for us, especially as we grow. We're really excited.
Thanks so much.
Yeah, thanks you all. Any other questions? I will be putting my email in the chat. Feel free to pass them to me and I will get you to Kurt or Mo and we will get you answers. We will make sure that you have anything that you need to get a Q-PAC array in your project today. All right, you all. Thank you very much. We'll see you next time.
Thank you.